Okay, so this is Mr. Peterson again. We're completing the Chapter 4 review for Algebra 2. And this last page, page 6, has some pretty difficult problems on. I'm going to do my best to explain them clearly. Okay, so if you look on this first example, number 28, and this is very similar to your problem, I've started by factoring this denominator so we can see that there's a shared denominator of x plus 3 and x plus 3. I need a common denominator, which means these actually have to match. And so what I'm going to do is fill in the blank here. This first one here needs another 4x plus 5. And you have to multiply that on top and bottom. If you were to cancel this off, you'd be undoing the work but getting back where you started. And that's kind of the whole point here, is that it's okay to multiply top and bottom of a fraction by the same amount. Okay, so at this point, we're sort of on the downhill section here. This is 20x, and then there's a minus in the middle, and a 4x there. So that's going to be 20x minus 4x is 16x. And then there's a 25 there, and a minus a negative 2, which is like adding 2. So 25 plus 2 is 27. And then we have our common denominator there of x plus 3 and 4x plus 5. Now I could write that like this. But you can see that there's no common factors. This top does not factor any further, so there's no pointing in writing it that way anymore, since it's not going to help us cancel anything. What I'm going to do is simply revert back to this version of it, and we'll get our final answer here. Now, I'm going to keep reminding you of this. You can't cancel with plus signs hanging around. So, for instance, tempting is that 16 over 4 is. Don't cross them out. Okay? All right, the next one here is already factored. You can see I factored this part, and it's down there. So we're going to look at this and say, well, we've got an x minus 3 on the first one, but what we're missing as we look down the line is a 3x plus 2. And the next one has that 3x plus 2, but it's missing the x minus 3. So our common denominator is now established. It's the combination of x minus 3 and 3x plus 2. The order doesn't matter. You could put those backwards, as it were. Okay, so let's collect our terms here. Here's a 6x. Let me show you better. There's a 6x plus a 4x. That's going to be 7x. Then we have a 4 plus a negative 12. So far, that's going to be negative 8. And then minus a 2. So negative 8 minus 2 is negative 10. Okay, last thing, we're going to revert back to standard form in the bottom here. And you have that written up there, so you can just copy it. Okay, that's adding and subtracting of rational expressions. And what I'm going to do now is work with complex fractions. And if you look down towards the bottom, we're going to deal with equations. And they're handled a little differently than the ones above. And there's actually a convenience here. When these are written this way, you can multiply this top by anything you want, as long as you multiply the bottom by the same amount. And just to illustrate here, if we multiply the top by 8 and the bottom by 8, you would actually have to multiply both parts of this by 8 because of the distributive property that's involved. So in the end, if that's what you chose to multiply by, the 8, you would have to multiply this and this and this all by that same amount. So what we're going to do is take advantage of that, and I'll show you how to set this up. You're going to say 3 over 4, but you're going to make a little ledge here and make this longer. 3 over 4. Now let me clean that up a bit here. You're going to make that a little bar a little longer, and then you're going to do the same with the two fractions down below. So here's the 2 over x. You're going to extend the bar, and then minus 5 over 1, and you're going to extend that bar. And that bar is for us to multiply things by, okay? So what you're going to try to do is clear all these denominators out. And so we're going to start with clearing out the 4. Multiply by 4, multiply by 4, and multiply by 4. And you can see it cancels there. And then I'm going to clear out the x. So I multiply by x, multiply by x, and multiply by x. And now this cancels. And I could multiply everything by 1 to cancel that 1 on the bottom, but it's insignificant anyways, so just cross it off. Dividing by 1 doesn't change anything. So other than cleaning it up and maybe simplifying, I think we're going to be in good shape. That whole top is just 3 times x, and the bottom, if you look right here, this is 8, and the back half is going to be minus 20x. And you're done with that problem. You should check if there's a number that divides into the triad, like if this is divided by 5 and by 5 and by 5, you'd have to cancel that out. Okay, so there's another example of this on number 31 here. So I'm going to start by writing the equations with, or the little fractions with a little bit of an extended bar on it. Okay, let me make that a little longer. And then the next fraction is 3 over x minus 6. So I'm just going to copy that and make room for some multiplying here. Then we have that 2. And I'm going to go ahead and factor the bottom down there. Let's see. X squared minus 3x minus 18 here. We have a 1 in front of the x squared. That's good news. We need 2 numbers that multiply to give that and add to give this. And I think I know what they are. That's going to be x plus 3 and x minus 6. Okay, now we just try and cancel all these denominators out. So in order to get this x plus 3 right here to disappear, I have to multiply the top here by x plus 3. And the rule here is you got to do the same everywhere. And that's gone. And what's cool is so is that. So we've simplified 2 things. We get two for 1 here. Okay, now we got to get rid of the x minus 6. And I'm sort of out of room here, but let me sneak it in here. X minus 6 right here. Yeah. There you go. X minus 6, and over here, x minus 6. My stylus is having issues. And here, x minus 6. Okay, so it cancels here and cancels here. And now you simply write down what's left. If you look up here, there's 4 times x minus 6. I'll write down 4x minus 24. And in the back is 3x plus 9, but we're subtracting it. Don't forget that. So I change the sign of both of them. And underneath you just have 2. So then when you simplify the top, you get x minus 33 over 2. And you could check this work. Just store something for x and type the original problem. That'd be a pain in the neck. And then type the final answer and see if they agree with each other. Okay, so solving equations, we're going to do a similar approach. What you can see here, if you study this for a second, is that I've just rewritten these fractions with a longer bar. And we're going to try to clear out the fractions by multiplying both sides by the same amount. And in the end, that ends up being just like we did up above. You have to multiply everywhere by that amount. So I'd like to clear out this 3x, and I'll do that by multiplying by 3x and 3x and 3x. And you can probably see right away that I'm going to have some trouble here with room. Anyway, that's gone. Here the x is gone. And on this one, when we cancel this, you're going to cancel the x, but it leaves a 4. So it looks like we still have to multiply by 4. So I'll multiply by 4 here, and times 4 here, and times 4 here. And when you do that, you're going to cancel these 4s. You're going to cancel this 4 and this 4. And then you clean it up. It's easy to get too much going on here, but you've got 4x plus 8 to start with. 4x plus 8. And I got that right here. And it looks like we got minus 9. And on the other side, we have, looks like just 5. So I'm going to take these both over. And so I've got 4x equals 5 minus 8 plus 9. That's 6. And if you divide by x here, you get a 1.5. So the value of x is 1.5. And if you store that value, you can type this side of the equation and then later this side of the equation, and you should get equal amounts. Okay, example 33. We want to clear the x plus 6, so I'll multiply both sides by x plus 6. And you're familiar with this. You multiply both sides of the equal sign by the same amount. Now, when you do that over here, you need parentheses around that. And that'll cancel over here. And then I'm going to multiply by 4x minus 1 on both sides. And now that cancels. So we're down to, if you'll distribute on the left, you get 4x squared minus x. And the right side, if you distribute it or you FOIL it out, you get x squared plus 8x plus 12. And if I take these over to the other side, actually I'm going to go the other way. I'm going to bring everything over to the left. That gives you 3x squared, and then minus 9x and minus 12 equals 0. We'll factor out a 3. And if you break this apart, you get x minus 4 and x plus 1. And that would lead us to answers of 4 and negative 1. Now, if you plug these in and try them, they both work. It's important to do that. If either one of them don't work, you cross it off and say extraneous. And you might have those. This often generates extraneous answers, so you should check your work. Store 4 and then type both sides, that side and that side. If they don't agree, you've got an extraneous answer on your hand. And often it'll give you an undefined or division by 0 error when it is extraneous. Okay, we got 2 more to do here. I'll do them a little more quickly, okay? You can see, to start this one, I've written all the fractions with those longer bars, but I've also taken this fraction and written it in factored form. Okay, so we need to multiply by x and by x and by x, and that'll cancel this x and that x. So this is now gone. I'll scribble it out. And then you need to multiply by x minus 1. going to cancel off several of these here. It's going to cancel off here and here, and those two. So when you clean this up, you're going to have, if you multiply those out, x squared minus 1, the middle term cancels. And then you got a minus x right here. And you've got an equals 5 on the other side. So when you bring this all to the left-hand side, it's x squared minus x minus 6 equals 0. And this one factors as x plus 2 and x minus 3, which then gives you answers of negative 2 and 3. And I think both of these are legitimate answers. I don't have my calculator with me to check it, but you would store the negative 2 and try it. I'm going to show you one that would fail. If we'd have gotten an answer of 1 down here instead of 3, then right here 1 minus 1 would be 0 on the bottom, and that would definitely fail. And it would be extraneous is what we would call it. Okay, I've got the next one set up, and I'd like to point out that I've factored this one down here. So we have to get rid of an x plus 4 to start with. And that'll cancel this x plus 4 and the original up here. Okay, and then we have to multiply everything by x. And that'll cancel this x with that x and this x with that x. And now we're going to clean up what we have left here. We got a 5x in the front part here. And in the back right here, we have to FOIL all that out and change all the signs because there's this negative governing the whole thing. So when you do first times first, you get x squared. I'm going to write down its opposite here. Outside is 4x and the inside is 7x, so that's 11x. Notice I'm writing the opposite. 7 times 4 is 28, and again, the negative sign kicks in, or the minus sign in the middle of the problem. And over on that side is 5x minus 2, or plus 2. Okay, we're going to take everything to the right-hand side. I want to get rid of this negative sign. That's why I'm choosing that. And when I do that, the 5x would cancel. And I would get 0 over here. X squared, when it goes over, is positive. And it's plus 11x. And the 28 would join with a 2 to give 30. So now we would factor this. Two numbers that multiply to give 30 and add to give 11 are 5 and 6. So that would give answers of negative 5 and negative 6. And I'm not able to show you a calculator while I'm doing this, but if you plug these in, store them for x, they both work. So that does it for the review. And it's a pretty tough test, so you guys need to really get yourself ready for this one.